I've been told that here is all the performance testing experts. So this is what the groups are. So this is a small engagement I did 2 years ago. So it's about how to measure performance sooner. Before I jump right into the topic about performance testing, so just so that I touch a little bit on the service virtualization piece. So this is the service virtualization technology was the key enabler for us to be able to complete this engagement. So, okay. So I'll go through the scenario what we did a bit later, but so here is, does this look like what you're testing? What are you building? This is your application in the middle, and the spaghetti map is all the integration that you have to do. So we might integrating with a file system, enterprise bus, or a mainframe, or third party, or you're integrating with, within the same company, a different department that's supplying a certain components that you need to integrate with. So this is normally a complex and heterogeneous environment that we work with. So doing testing in this environment requires, for example, system testing in this environment or integration testing requires all the components to be ready for you to be able to do that testing at the moment. So that itself is a challenge. So we are resource challenged. We short of. So normally in the development phase that we are, everything is packed into one machine. And then when you get to more of the QA or the system integrated environment, you have more spread out environment. So this is one of the challenges that we're trying to see, how can we address this and be able to do production-like performance testing or testing earlier on to move that, shift that whole performance testing to the left of the development life cycle. So here is some of the key benefits, obviously doing service virtualization. So on the left is your integrated environments, your system integrations, and you're integrating with data warehouse. Whereas on the right-hand side is the application that you are building, and also the application that you're going to test. So everything else that you are interacting or integrating with, we're trying to simulate that. So we might simulate a database that you need to integrate with, or we might simulate a third-party service, or application or app that you integrate with. For example, a lot of SAP system, big system, most companies will not have one for development. So you normally try to wait to do your end-to-end testing of the SAP environment to the very end. So in a system or the production level. So obviously the service virtualization is trying to address some of the challenges that we have, for example, unavailable, inaccessible infrastructures, resources, and also the dependency in software. So things that might be supplied by third party. For example, if your application goes out and call a payment gateway, every time you call them or every time you test them, you might buy a package. So if you exceed that package, you need to pay for every message that you send out or every interaction you call for a payment gateway. So you need to pay for that. So doing that in the development phase, it costs you money, right? So some of impractical hardware. So what that means is a lot of companies will have mainframes, some legacy systems in place. So it's probably no SOA based. So you're still connected to a mainframe. So access to these mainframes is normally, I haven't heard people able to do that in the development phase. So normally we try to bypass the testing or any integration to the back end of the legacy systems to push that to the very later end of the testing cycle or the development life cycle. Okay. So here is an example of a delivery pipeline. So normally you from your development, SCM, build, so that's the end-to-end. So all the way from your package repo, deployment, test, and staging to your production. So that's the first line. So second line there is basically your environments. You have your environment mapped out according to your development life cycles. So as you can see, what I'm trying to highlight here is the number and the amount of infrastructure that is required in the non-production environment. So non-production environment not only been seen as it's not revenue generating, so it's a lot of emphasis on reducing the amount of environments that you create in your non-production environment. So with developers, they like to keep their environment running. So they, now we have clouds, people like to keep instance running, provision environments, but it's a hard task to ask them to pull the environment down. That's a different discussion altogether, but how to achieve that. So we have our VMs are growing, our number of environments are growing. So on that you have dev, multiple instances of dev environment, multiple instances of integration environments, and then you have databases, mainframes. So you will not have access to the mainframes or the third-party services, at least at the development phases. And then you go and move into your SID, your QA, your SID. So those are the pure significance to show that the number of environments is required. And then you add on the number of resources required to actually maintain those environments, upkeep those environments. So for example, you might need to do a QA testing. So you finish your first round of development, you push to QA. So they need to set up all these integrated environments for the test to work. And then you push on to staging and production, obviously. So what shift left is a concept here is that instead of having all those environments for dev and every instance of dev, integration, QA, and SID, we virtualize the interfaces to those environments. So you are actually you can actually do production-like performance testing or testing in an isolated piece. You're testing your application. You're not testing the system. You're testing your functionality of your application. You're not testing every other component that's associated to your application. So you're virtualize the interfaces, for example, the database, JDBC, or a mainframe interfaces, or third-party Wistful web services. So you virtualize them. You know the functionality. They're going to send you the behaviors, but you are testing your application against them. Right? So just sheer amount of infrastructure is saved using this technology. Okay. Now, so this is the actual work that we did. It's with a government-owned superannuation company. So remember, a couple of years ago, we had this super stream. So all the super companies need to comply, and ATO have this, super stream concept in there. So it's a government-owned superannuation company. They didn't have a lot of competition in the past. So they really, given that the super stream move and the change of the whole industry, they really need to start modernizing their environments. So from that, they started to look at new service-oriented architecture. So in the past, it's always application to application. So application to talking to databases, point to point. So there was no middleware involved. So they start looking at some new service-oriented infrastructure, and they chose TIBCO as their integration layer, as the integration service bus. So speed to market is crucial to them. So from someone that has never need to deal with competition, and now they enter into a competitive market. So I worked into a company, I can see the whole environment and the whole atmosphere. People trying to change, but they got all the burden. They need to carry all the burden with them, the legacy systems as well. So speed to market is also an important thing for them. So what is the business problem? So obviously it is they just introduced a new integration platform, which is the TIBCO EMS layer. And they obviously hired the consultants, they hired the TIBCO company to set up the environment for them. So they would like to know, if the environment is set up to a spec to what the consultants or what they originally told them they are. So they just need us to come in to do the verification for them. See, okay, they say that we can handle 1,000 transactions, for example, 1,000 transactions per second, example, do they really live up to that standard? Or things like that. So just testing the functionalities and testing whether they deliver what they said. And then so the other problem is the lack of test automation and the integration of testing knowledge. So as I said before, they come from a background where it's point-to-point, so they literally have no integration testing knowledge, this company as a whole. So the lack of test automation, all the testing in the past has been done manually. There isn't any automation. They do have some automation tools in place. They start to introduce regression testing, some of the application level, so the application end-to-end performance testing in a small amount, so that they don't understand the concept of integration testing. Minimal environment available, so they're just starting up, so they have one environment, development environment, the other one are probably in the staging or the production environment. So it's really minimal amount of environments available. So they work in a shared environment. So while we're testing this middleware platform, there are applications using this platform. They're actually doing their testing, developing the applications, doing their testings, using the platform. So we need to, when we're doing this engagement, we need to bear in mind that there are other people with an effect if we're actually doing an end-to-end, or we're doing a capacity or a performance testing of their middleware, because we're going to affect all the people testing and developing the applications. And then the minimal environments, okay, there isn't an understanding of scalability. Obviously, this is the whole concept of the SOA, the platform is very new to them, so the concept of scalability is still new to them. So this is just a rough architecture of what they presented to us and what they've shown us here. So they have firewalls in place, and this is the typical implementation. And then you see on the, I'll show you if I can point here. So here is all the applications that's hanging off the EMS server. So there are a number of already established applications, just simple, they just start building those applications, hooking onto the EMS. So people are building them, people are testing them, we're all sharing the same environment when we do this performance testing, or do this testing. So solutions, so test automation, we need to, for we to do any performance testing, to get started, we introduce some unit level tests for the services. So those are some checkpoints, verification points that we need to put in place. So we introduce that using our technology in the integration. So we're basically getting the operations, we hook onto the business work projects, and then we're able to see how the flow of messages. And then we did some unit level testing of their services. And then we virtualized the back-end systems. So that's an important point there. Because, as I mentioned, they have a limited environment. There are multiple people sharing, or multiple, who are developers and testers all sharing the same platform as us. So we need to minimize the effect, how we do our work and without affecting others. So we have to virtualize all the endpoint systems. So all the application I was pointing out that we're using this platform, we need to virtualize them. Basically, the ESP itself is pointing to a virtualization rather than going to the real application. So they will basically cut off their connection. So when the performance load comes through, it comes to our simulation. And so we also develop a benchmark test to determine the capacity. So we run through, we stress tested and always also soak tested. So we run through, leave it over the weekend on the minimum amount of load and see how the system performs. And then obviously that becomes a baseline. So this is what we did in terms of a solution, a simple way to say. We're using our rational integration tester to import all the business work projects. And then that as a baseline, and we start building those unit tests. And then using rational performance test agents, so you're putting agents onto the EMS servers. And so obviously there's typical gateways and typical integration environments in the middle. And then when the load starts to goes out to the application, the databases, the application that they're still using, we're using the rational virtualization server to handle all the loads from our test that goes, that will prevent that from going to the real applications, hitting that real application. So their application still works, they still interact with their typical environment while we're doing our performance testing or functionality testing. So they will not see any ambiguities if these are coming through from us, because we put that buffer layer in place. So obviously this is how we, as we go through, we need to get more details in terms of which area do we start cutting off, and what areas do we need the detailed wisdom files and XSDs and start simulating them. So this is one of the application. It's a sequence diagram or message flow of their payment services. So we have obtained this sequence diagram along with wisdom files and XSDs, and then also the sample messages flown from the middleware. So this is where we start to decide, okay, where is the cutoff point that we virtualize? So all the lines that are going through the swing lines, all the messages that flow through the swing lines, so we decide, okay, there is a point that we need to, for example, here, for this payment gateway, if we put just say we cut off right there. So the first swing line, between the first two swing lines, so when we cut off there, so that will be the point that we start simulating the behavior and feeding back to the middleware platform, sending the message back. And then rest of the behavior will be simulated. We will building those behavior to the stubs. We're feeding our enterprise bus with those behaviors and responses. So we'll build that into our simulation. Any questions? Okay, so it's a bit small, but as we progress through our work, we publish out the simulation. So this become a centrally hosted simulation that many people can have access to. So when you start doing service virtualization, you first start running on your machine, you just want to test out the simulation if it works. And once it's working, then you publish out to a server where everybody can access. So this will sit in place and just representing, an interface to the real system. So if you have this simulation up and running, for example, the one that I have some numbers against to. So if you have the simulation up and running, it tells you it's a simulation that's catching all the load to it. So for example, this claim process has processed around 322 transactions so far. And it just keeps sitting there catching all the loads that we send through. So basically for our performance testing, we send a dummy load through, we tested a specific service in there and really load up that particular service. And then, this is the virtual, so claim process, instead of going to a real system, it's been catched by our claim process as a simulation. Any questions before I go on to the benefits? Okay, Andy.
So the ESB was really what was under test. It was really
yes.
the TIBCO and the applications that were connected to it were really what we were simulating.
Yeah, thanks, Andy. So yeah, just to point that out. So obviously the ESB, the typical ESB, is what the new bit is being introduced to the company. So the client really, they're asking us to say, let's have a look. Do they really, deliver to what they said they did, and let's have test this piece in isolation. So we have to block off all the affected applications and feeding the ESB directly. Yes, Theo. Testing the real end system applications.
So part of your ESB connectivity, you have a bunch of other
So what we did, so we integrate with TIPCO, so TIPCO business work. So we pull down all the TIPCO business work projects. So thinking of ESB, so they have internal services, or external services, right? So we put in the project, so we start testing the internal services as a starting point. And then because we do not, so I didn't get the chance to test the endpoint applications at all. So what we did is, our mission was there to isolate that environment. So the first thing we do is we get the interface of the endpoint systems and start simulating them. And then driving the load through the internal services. Okay, so, yep.
How many environments did you end up simulating, and what sort of load were you feeding through the simulation?
So we did a couple runs of tests. So there were 5 applications that we have to simulate. So the endpoint application we have to simulate. I think that's 5 applications. And then we did soak tests, which is probably just running 20 transactions per second over the weekend. And then the stress test, we loaded up to 500. I think that was the maximum that we did. Transaction per second, that was the load. Okay. So in terms of the benefit, what we did find out through this short period of engagement. So I was only there for a week. Before I went on site, I have limited knowledge. I literally have not seen TIPCO ever in my life. So the benefit we're able to discover from here is they had bottlenecks in their connection pool were discovered earlier. So obviously their architecture diagram, just let me flag. So their connection pool there, so they were, once we put the load through, we start seeing a lot of transactions start dropping. So the connection pool is not taking any of the further transactions. Oops. And then the maximum thresholds for the throughput within the bus was discovered. So basically, with the connection pool issues, and then what we can put through to the bus was really limited. And then when you bypass the connection pool, you can also load up a particular service. For example, once you bypass the connection, and then you can say, okay, particular service, I want to really test these services out. So in isolation, I was able to say, okay, I'll just load 500 transactions per second. In a scenario where if a certain services were responding 2 milliseconds slower than expected, how this affecting downstream systems or downstream service performance. So in that was also a scenario that we tested using this technology by doing the isolation. So we can ask the simulation to respond with a delay, or itself with a 2 millisecond or 7 millisecond delayed. And then the error handling call was also fun, and that's a very funny one that we actually overflow their database with, because we keep pumping through the load and then there were no exception catching of the error. So we end up basically the database wasn't handling. That was shut down, and we just couldn't continue our testing. So the next day when they came back, and they were able to fix that issue, so we continued to move on from there. So the correction error, all the actions we did was we discovered these problems very early, and then with working with the TIPCO admins and as well as the development team there, we're able to address all these issues and all these actions midway through the development. And then the tests were reused. So another benefit of this is whatever we were working on, the guys, the one who had a manual tester, he's probably around 50s or 60s. He had been manual tester all his life and never touched automation. So he was, after sitting down with us, just watching what we did and how we pull in the projects, how we start doing the testing, he was able to maintain what I did there. And he was using that as a baseline to keep running those tests over and over again. So that was another benefit, again, from this engagement. lessons learned. I learned a lot from this engagement. Integration knowledge is really essential here. So obviously asking the right questions and having the all the interfaces, understand XSDs and how they work, and how do you get past those errors, and and then working with typical admin as in general, they will have when you need to put a performance agent, you need to have all the monitoring systems. How do you get that back into a tool, and how does the result get stored? They will have all the tips for you. So that was a very important step for me. And then data. So data is a performance testing, as you know. Data is a very important piece, and you always get burned out. You never have enough data. So in our case, we were able to reuse. We simplified the scenario that our data can be reused. So the file that we're dropping into the typical ESB can be reused and resent over and over again. And that's probably a good part, that we isolate the downstream environments, as in it never got processed by the files that we sent through, never got processed by the end environments, or we bypass that. We're just giving a response back. So, and then the firewalls are tricky. So I would try to do it before before getting to the firewall. And I guess the really hint is really try to get the small bits working before it gets tricky, and try to understand on the firewall how to punch holes through, and etc. So that's probably all the lessons learned, and the whole engagement lasts around a week of our on-site web. We have no domain knowledge of how supervision industry works, what application they have. So we basically went in cold, and I have no pre-existing typical environment knowledge. The tool itself was able to pick up load the project in, and able to understand the intricate connections between different services. That was a great help. And got a lot of help from the typical admin team as well. Okay. Any questions?
I'd like to know more about how you manage the data issues. Did you just select a certain atomic transaction and then get a set of data to populate that with, or did you just record them and replay them? And how did you manage it? Presumably you stubbed out the back end, so presumably all of the requests you were making didn't have any other dependencies in that chain.
Yeah, so we had a few data-driven simulations. So the stuff that the simulation that we built for the application, we have a data-driven simulation. So you feed random, so it gets us random, well not random, but it goes through the data pool.
So you had clean data to start with?
Yes, we had clean data to start with. Yes. Yep. Yep.
How long does it take for you to build a service on average? Like what you said, you did 5 services, is that correct?
So we simulated 5 servers. Yeah.
How long did that take you to build that range?
So within the week, obviously learning about their process and stuff. The service itself, when I got all the files I need, with the Whistle file, XSDs and sample messages, when I was able to, it really depends whether I'm able to, the speed of how quickly I can simulate depends whether I can record or not. So if you can start recording and start having all the simulated, all the message I can record that, that really speeds up how I simulate the services and how much logic I can build into that service quickly. So if I start listening onto the EMS and start capturing all those messages, and then that become basically my data pool almost, and all the messages in there that can convert it to the data pool. So once I spend all the time with the infrastructure trying to make that happen, and that simulation comes really easily. I think I just use the sample message equate and turn them into a simulation. Yeah. But without that, it would take time manually. So obviously we're putting the Whistle files, putting the definitions, and that would probably take a little bit more time than the recording method.
So if you have everything, is that 10 minutes? Is it an hour?
Well, if I have everything, so I can do recording, it will take us say 15 or 20 minutes just to get a simulation going. Yeah. Yep.
So all the performance testing and the environment simulation was all done in 1 week?
Yes. 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 Yes.
Sorry, the profile of that service, what sort of distribution did you use? Was it just like a uniform distribution, average 2 seconds, whatever?
So we were different stage. So obviously, for the soak, when we do the soak testing, we didn't really pick any profile, of the distribution. We just sort of put in 20 transactions per second through.
But the way that the service is meant to react obviously follows some sort of profile as far as a particular distribution. So a dumb way to do it would be a uniform distribution of an average of 2 seconds. But if you're doing that, then the connection pools you actually have are probably going to be a reflection of what sort of profile you set up.
Exactly.
It may not be real.
Exactly.
So for instance, a normal, I shouldn't use the word normal, but a normal profile of a back-end service probably follows something like a Poisson distribution with a long tail. And that's the sort of thing you'd normally want to do because that would mirror real life, and so that would change what you get out of the connection pools.
So we tried all different ways in there. So we had the method of trying different uniform, and then the throttle, the different profiling we can do.
How did you work that out?
So the tool itself has So basically, the tool itself has different profile that we can select to hit the service.
But how do you know which one to use?
We don't know.
So
yeah.
my point being that if you guess, that's going to be a reflection of probably what happens in your connection pools. So whatever you guess, that's going to be reflecting. So you may not have actually got the right result from that.
So as part of this engagement, because everything was done in a very short period of time, and the client itself doesn't know what's got put in place. So we don't have a lot of information from clients. Okay, for example, this is too, can handle this much of connection, for example. So we tried different basically profile to hit it. Right?
Didn't you say that you adjusted the response time from your simulated backend server?
Yes.
That's kind of like a worst case scenario anyway, isn't it?
Yes. Yes. Yeah.
Did you randomize those response time on the back stops, or it was just constantly 2 seconds, 2 milliseconds responses?
I didn't have all the